We're going to do just one thing from the hyperbola section because you're going to need to graph one, but that's not hard to do if you remember the parts, and we'll use this to practice a graphing one anyway. And then you're also going to have to write the standard form, given the general form like I have given you here. So we're going to use this one as an example, and I didn't do one of these with the ellipse because it's really the same basic idea. You'll have to do this for an ellipse, but it's actually a little harder this way, so this will be a good one to work it out with. We know this is a hyperbola because of the fact that there is a negative for one of the squared coefficients. So the x squared and y squared, for all of the conics, this is where you can tell whether it's a hyperbola, ellipse, circle, or parabola. And for a hyperbola, it's negative. So what we're going to do is put the x's together and the y's together. The coefficient we're going to move to the other side. That's the first step for doing these, is put it up in the right order, the right setup, so that you can complete the square for two of them, if necessary. If it was a parabola, you'd only be completing the square for one of them. So what I'm going to do here is take out the coefficient. I need to complete the square with the x squared being by itself and the y squared being by itself, and being positive, so we'll deal with that. So I have to take out a common factor just of the coefficients, not with the x there. So minus 2x, and leave some space to enter the correct c in here to complete the square. Minus 9, from that gives y squared, and negative 9 goes into negative 18, positive 2 times. Watch out for this negative thing when this happens, because that's one of the main common places people tend to make mistakes. Okay, now we can complete the square here. So the c that we need, the correct c for this, will be the b over 2 and squared. So that's negative 1 squared, which is just 1. So I'm going to add a 1 here. Well, normally if you're adding something to one side, you add that same thing to the other, and that's what we're going to do here. We're adding a 1 here, we're going to add a 1 here, except that's not a 1. Looks like a 1. You write a 1 just like you normally would, but it's not a 1. That's because of this 4 out here. Everything in here, that's not x squared, that's actually 4x squared. This is actually negative 8x squared, negative 8x. And therefore this is actually 4. So if we put a 1 in here, we can't bring it over here unless we also apply that 4 to it. So we actually have to add 4 over here, not 1. We're going to do the same kind of thing here, where we're going to take the b, c is equal to 2, which is the b, divided by 2 squared, which is 1. 1 squared is 1. So we're going to add 1 here. But this isn't really a 1. You have to multiply it to the negative 9. So really we're adding a negative 9 here. So if we're putting a negative 9 on this side, we have to put a negative 9 on this side. Now we can clean it up. This is a completed square, x squared minus 2x plus 1. That happens to be x minus 1 squared. And we have a 4. So it's 4 times x minus 1 squared. Minus 9 times y plus 1 squared. Remember, we're taking half of the b and keeping the same sign. Half the b and the same sign. Plus, this is a trinomial square, and that's the factoring of it. And that's the trinomial square, and that's the factoring of it. 41 plus 4 is 45. Take away 9 is 36. We have to have a 1 over here, so let's divide by 36. And don't make like this like negative 0.25. You know you have to have a number on the bottom, or this won't be a negative or a 1/9 what it is. You do have to have the 9 on the bottom of it, because that's where you have your a or your b. In this case it's your a, because the negative 1 is always second, is always with b, or b. This is a squared. Minus y plus 1 squared, and 9 goes into 36 4 times. So our a is 3 and our b is 4 in this case, or b is 2 in this case, equals 1. 3 and 2, or 3 squared and 2 squared. And there is our equation. Now, if we were to graph it, which is a separate thing, but it is something you're going to have to do on the test. Let's make ourselves a graph. And then 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8, 9, -10. Okay, I actually don't need to go down that far, but I have that much space, so I guess I'll use it. So what I'm going to do is find the center, which is +1, -1. So center is 1 for the x and -1 for the y, 1 and 1. So there's the center. A is a distance of 3, 1, 2, 3, 1, 2, 3. B is a distance of 2, so it's 1, 2, and 1, 2. So now we're going to make that little box to allow us to make asymptotes. The asymptotes run diagonally through the center. And then we go to the endpoints of the major axis, which is here, parallel to the x-axis, so it's the 3's. And that's where now we can make our arms of the hyperbola. So remember these steps for graphing it. Is you find the center, you go out the distance for A both sides, the distance for B both sides. Use those points to enable you to find 4 corners where you can run asymptotes through it, and use those asymptotes to guide the arms of the 2 parts of the hyperbola, starting from the endpoints of the major axis. And there's our hyperbola graph. So this problem actually gets to do 2 things. It's a review of completing the square and the steps for changing from general form into standard form for hyperbola, and therefore also for an ellipse and for a circle. Except for a circle you don't divide over here, you leave it so you have a radius. But for an ellipse and hyperbola you divide to get 1. The only difference here is an ellipse would have a positive here instead of a negative. And for hyperbola you graph it as I showed there with the center, A, B, the box, the asymptotes, and then the curved arms. So be prepared to be able to do that for hyperbolas for me. Thank you.